Okay, welcome everyone to the June 2021 Trees Around the Globe Student Research Campaign webinar. Before we get into the meat and bones of the webinar, I want to show you another really cool tree that I came across with some of my, Googling. And this is, like I showed last time, I showed a really amazing tree last time. This is and my pronunciation will be awful, so I'm just going to call it what it says here on the right, the Zoroastrian Sarv, and it's a 4,000-year-old tree sprouting about the time that the people of Central Asia were developing the wheel with spokes, which is just mind-blowing to me. It's Iran's oldest tree. And I know, Dorian, you lived in Iran for a while when you were younger. So
I did. It was such a wonderful opportunity. Yes.
great. And so I came across this and I thought this was just amazing. It's Iran's oldest tree. It's a beloved national monument in Iran. This Zoroastrian sarv, or the cypress of Arbarka, is estimated to be 4,000 years old, and its name implies that it's a cypress tree located in central Iran in the Yazd province near the city of Abuka. So this is just a really cool thing I wanted to show you, because most people, when you know, I'd say 99.9% of people would look at this tree, and if they didn't know anything about it, they'd never figure that it was a 4,000-year-old tree. Some would, who are the experts in looking at trees and land cover and things like that. But, honestly, I wouldn't figure. I figured it's an old tree based upon its size, and you can tell its structure, but I would never figure that it's, potentially a 4,000-year-old tree. So getting started, we're going to talk today about the people behind the pixels, understanding rapid forest changes to the Andes Amazon region. And thank you all for being here. I've had a lot of interest in new members. There are some new members here, so thank you for being part of this webinar and part of the campaign. And I know that this is one of the great reasons why we want to continue this Trees Around the Globe student research campaign. And I should mention, as a disclaimer, as you know, Globe campaigns are, set up to be a maximum of 3 years, and we are ending the third year of this campaign in September. But with that said, we have submitted an extension for 2 more years for the campaign to the Globe Implementation Office. This is a request that we sent based upon a lot of the folks who, there are some couple campaigns that maybe, are in their third year right now. So, we want to continue this campaign. We see the importance of it, and we hear the importance of it from all of our campaign participants. So Globe set out a call for campaign proposal extensions, extension proposals. So we submitted this a few weeks ago and hope to hear something very soon about this. And we have the support of, folks at NASA, folks on the campaign as well. So we're super excited to hopefully get that extension. So keep your fingers crossed and do what you need to do in order to, will this campaign to continue. So today we're going to talk some really awesome tree stuff, forest changes. So as you know, here's our core campaign team. I bring this up every time. I don't need to go through everybody's name, but you should know all of us by now. So today's webinar agenda. All right. If you haven't said so already in the chat, please say hello, where you're from, and anything interesting about your location, what the weather's like, what you see out your window right now, if you happen to have a window nearby. If you don't have a window, say something else. And I'm going to go through some metrics as I always do. And then, as you know, the 2021 Community Trees Challenge came to an end on May 15th of this year. So it was a 1-month challenge, and I have some metrics on that I want to share with you. And then Dorian will introduce Dr. Paulo Murillo Sandoval and Peter Nelson. So our featured presentation will be by Dr. Paulo, and he will be talking the people behind the pixels, understanding rapid forest changes to the Andes Amazon region. And then after that, we will have an extension of that presentation with Peter and Dr. Paulo showcasing how students and educators can use the Landsat time series for their area. I know this is right down, Peter's alley. This is what Peter is an expert in. So I'm super excited to hear about this and see this. And then we'll have a wrap up open discussion, and this will lead us into some things that we want to do for webinars in July and August, which we're planning right now. But we want to ultimately in July and August have those webinars as preparation for getting, educators and students for the upcoming, when school starts back up again in many locations in September. I know in the Southern Hemisphere, it's a little different. Things start up differently, but we want to, no matter where you are, get, try to get you as prepared as possible for the next year of the campaign. So we're running on a weird time right now because we're hoping the campaign will continue in September and go for the next 2 years. But this summer we want to get you prepared for, student research, looking at online tools, learning how to take land cover observations, whether it be the simple part of that or the more advanced one where we figure out the percentage of what you see in your land cover observations, as well as also taking tree guides. So we will be then training you also on, how to take the tree guide observations, how to take the land cover observations as well, because we want this to stay fresh, in your brains and fresh for new students who may be coming in, at the beginning of the school year in some instances. So we want to talk this open discussion with you informally about what are you going to investigate in the upcoming year? What do you want us to feature in upcoming webinars? What are some ideas for topics, content, and speakers that you may know of in your local area that you think would benefit the entire campaign? Do you have people, in your area who might be great speakers at a future webinar? That's what we want, because as you know, as Dorian mentioned earlier, we are a nice, close-knit community, even though we're spread out across the globe, right? So this is why we love this campaign so much, because we are always wanting to have people come in from all different walks of life, all different locations, to promote the science of trees, land cover, greenings, carbon, so all of these things. And then we also want to put a call out for something called Champion Students to lead the August 2021 webinar. This is something that Peter Falcon thought of, that how about we bring some students into, to lead the webinar. We don't know if this is going to work yet, but bring them in to lead at least part of the webinar, maybe all the webinar, to have discussion about what students and educators want for the campaign coming up and what we can do as far as looking at these first two questions. And then the kind of the blanket question, how can we help as a campaign? So let me get started with some metrics here. Okay, and I always like to, include some of the earlier ones from the first year of the campaign, but I want to draw your attention to where it says full campaign, September 15, 2018 through the present. All right. Here we have, since then, we have over 36,000 tree height measurements coming in from students and citizen scientists from over 15,300 global sites. We have 19,000 plus land cover measurements coming in from students and citizen scientists from over 12,800 global sites. And then we have almost 21,000 greenings observations from students. And as I mention every time, 90% of these are coming from the students and educators who are part of the European Phenology Campaign, and our colleagues in the Czech Republic who are leading the campaign, the European Phenology Campaign, are doing such an amazing job in the spring and fall versions of the campaign in getting them, the participants, to get out and take these greenings observations, these green ups and green downs. So with that said, we have over 76,000 measurements since the beginning of the campaign from over 28,800 global locations. And that's just amazing. And we show that because that is a lot of data that students can use to look at they can look at the change over time in just the last 3 years for student research projects. And with this campaign, we've had 33 webinars and 8 specials, so a total of 41 webinars related to the campaign. 33 webinars, that includes the 5-hour workshop last month, but it also includes all the monthly webinars. And then the 8 special ones are ones that we've focused, where we've had joint webinars between different campaigns, like the European Phenology Campaign, We've had campaigns with Globe Africa, Globe Latin America, things like that that are recorded and you can access on our campaign page, our campaign webinar page. We currently have participants from 55 countries, and we have right now 40 blogs. These are just blogs that are campaign. These are not NASA Globe Observer blogs. These are just ones that are on the Globe website as part of our campaign. We have 40 blogs in the last 3 years with over 116,000 views. So thank you all for checking those out. So lastly, with the metrics, from April 15th to May 15th, 2021, we celebrated trees by having a 2021 Community Trees Challenge, Science is Better Together. And as you can see here on the bottom, we had, during that time period, we had 2,441 tree height observations from 1,733 global locations. What makes this really cool is that these numbers coming in makes just over 7% of the total tree height observations from just over 11% of the global locations since the release of the NASA Globe Observer Trees tool on March 29th, 2019. So since the release of the Trees tool, there have been almost 35,000 tree height observations from 15,000 global locations. And if you're not muted, could you please mute your microphone? Or Dorian or Peter, you could find out who that is and just mute their microphone, please, because I know there's a lot of feedback coming in. Thank you. So with this Citizen Science Community Trees Challenge, this was a great success because it was the first time we've ever done this. Of course, we're not at the numbers that we see during the NASA Globe Observer Clouds campaigns, but this is relatively new compared. This is actually almost 3 years younger than the cloud observation, because the cloud observations were released on the NASA Globe Observer on Earth Day of 2016, and the trees tool on NASA Globe Observer wasn't released until March 26th of 2019. So, we're about 3 years behind as far as people seeing what they can do with this observation on the NASA Globe Observer. So, but we're super excited that we have this, and you can see the map here where all the Trees Challenge observations were coming from. And if you go to the NASA Globe Observer site into the news section, you can read more about this with some additional metrics as well. So as you know, we're running this year with this scaffold structure, and we're currently in this phase 3, submitting and presenting student research and the workshop. So what we're going to do today is kind of a we talked about what the students have submitted. We had the workshop last month. So today, what we're going to talk about is, we're going to have the presentation from Dr. Paulo, and then Peter and Dr. Paulo are going to, talk about how you can, kind of focus on the research that Dr. Paulo has done, and then how you can look at Landsat, time series data in your research, how students can do this, how teachers can show their students how to do this in order to get ready for what we want to, plan for the future of the campaign. And then July and August, finishing up year 3, that's where we're going to have the training sessions, perhaps have the students, serve as champions to do this. And if you have any students in your classrooms or programs that you think would be a great fit for helping to plan and lead a webinar sometime in August, please let us know. That would be great for us to know. And then, you can let them know, hey, this is what's going on. You can have them contact us. Make sure that you CC you're going to be CC'd on the messages, because we want you to be involved with this as well if they're your students. So we're excited about this. That's just in planning stages now. So don't feel really pressured right now that we need an answer directly right now, but in the near future we would. So let me finally mention the Globetrees Family Guy. This is a place that you can go to learn all about trees through these science journeys. And you might have heard about this last time, but we have it divided into age groups, basically. If you go all the way to the right, that's the youngest group, the Sprout Science Journey. So students, really young children up through early elementary school. And then Seedlings is for late elementary school through middle school. And then the saplings gets a little more complicated. That is for high school students and adults. So you can ask, learn, observe, and create all about trees. There's things including about land cover, but it focuses on different aspects like tree height and carbon and habitats and wildlife. So you see all those strange little icons in there, like you see a tree, you see a bird. So all those things represent the different science areas that we are focusing on related to trees. So you can check that out. There's the URL at the bottom. So you can check out the Globetrees Family Guide. And anybody can do it and learn all about trees in different ways through asking, learning, observing, and creating. So let me pass this over to Dorian, and she can introduce Dr. Paulo Mario Sandoval.
Fantastic. Thank you so much, Brian. Hey, and looking at those stats, I love it that you go through them every month, because I love watching them fill up, and I love seeing places, around the world where we didn't have tree observations before that we now do, and land cover as well. So it is our honor and privilege to welcome you to joining our community, Paulo. Paulo is an assistant professor at Oregon State University. He uses dense remote sensing time series to evaluate and capture climate change and climate change's impacts on the landscape, which are associated with the complex, co-evolution of natural and social systems. He is interested in monitoring agricultural systems, forest transitions, and their connections with socio-environmental issues, things such as armed conflict and the impact that those have. Really, really fascinating. And if we look at the next slide, I believe we are ready for Dr. Paulo.
All right, I will stop sharing.
Yeah.
Dr.
Thank you
Paulo.
so much, Brian and Dorian. Well, I have to say first that I am no assistant professor at Oregon State University. I am going to be an assistant professor in Universidad Tolima in Colombia. Currently, I am doing a postdoc at NASA, working with mangroves in a group that focuses exclusively on mangroves, mapping mangroves globally now. Then I graduated last year. I defended in November last year. Then what I'm going to present today is basically some outcomes from my research in Colombia. Let me put my video. Oh, yeah, good. I would like to share my screen. Can you, Brian, give me access to share my presentation?
And Paulo, do you see how Oh, very
You can
good.
go ahead now. I had to change the permissions. It automatically resets every webinar. So go.
Oh, okay.
There you go. Looks good.
Looks good. Perfect. Okay. Yeah. Well, this is part of the dissertation that I did last year. Then what I'm going to present today is basically a summary that you guys can understand a little bit what has been the relationship between civil war in Colombia, armed conflict, and the process toward peace in Colombia, and all the land cover changes associated with the transition towards peace, especially in the Andes Amazon region. Just for starting, it's important to say that there is a very interesting relationship between conflict or war across time. War is something that is common. Conflict is something that has happened during the last 500 years in our planet. And in this plot, we can see some kind of variability across the time in the amount of people that have been killed because of conflict. And this blue line here at the end shows that probably during the last 50 years, the amount of people that have been killed because of conflict, because of war, has decreased a lot. But it still is very controversial, all these numbers, all these problems associated with conflict, and also the association of this conflict with the land cover changes that we can see. Once people think about like, oh, there is a war, there is a conflict, in some cases, people think about the destruction of buildings, the destruction of facilities. migration of people, right? This is an image in Germany in the Second World War. And currently, for instance, in Syria, we also can see a similar pattern, right? The destruction of houses, um, the destruction of hospitals, which is terrible, right? But conflict not only occurs in urban areas. Conflict might also occur in areas that has forests, in areas that has agriculture. Then in some cases, some illegal groups, they have some specific environmental rules, and they cut trees, for instance, to sell wood or for establishing coca farming for coca production. Or in some cases, uh, given that conflict is very, very heavy, there is a bunch of confrontation between different parties. People, in some cases, they leave their farms, and there is a secondary forest, of recovery of forests in these land abandonment regions. Then all these changes are very common and are associated with processes between conflict and peace. But something important to mention is conflict occurs globally and mostly in tropical regions. We can see here that these red points represent confrontations between governments and rebel groups, and the green color represent forests. Um, if we go to like a zoom for some specific countries, we can see that, well, there is an association between these confrontations in the Colombian Amazon and forests, also in Africa, in Congo, in Myanmar, in Asia. We can see that there is an association, right, between forest cover and this confrontation between different groups. Let's go to Colombia a little bit. Colombia is about 4 times the size of Oregon State. More than 60% of the Colombian forest remains, the Colombia remains as forest. We know that Colombia also hosts a bunch of biodiversity, a bunch of different species, and the Amazon is a very rich country in biodiversity. But at the same time, we have been dealing with a bunch of different issues associated with our conflict. We have different groups, guerrilla groups, which are left-oriented groups. We have also paramilitary armies, which are ultra-right-wing groups. And during the latest 50 or more years of conflict, more than 260,000 people have been killed because of this. More than 200,000 civilians has been killed because of conflict. After Syria, Colombia is the second country with the highest amount of IDPs, internally displaced people. People that was killed by guerrillas is about 35,000, whereas for paramilitary forces is about 100,000 people that have been killed. Then this shows that this Colombia is a very nice place for studying, for evaluating this association between forests, between changes on land cover, and also the impact of conflict over there. Something important happened 4 years ago in Colombia, well, 5 years ago in Colombia, and the Colombian government and this rebel group, FARC, they finally signed a peace agreement. This was a very important event in Colombia because all these rebel groups that were living in the jungle, living in the Amazon, in the Andes area, they actually left the territory. What happened, this is like, well, Santos, the former president in that moment, he got the Nobel Peace Prize in 2016, and FARC, they got some political participation into the Colombian Congress. This is in general, that was the part of the agreement, right? Have some political participation, that this legal group has some legal rights to establish a better political agenda in Colombia. However, all these processes about the beginning of peace, of the end of the conflict, generates a lot of deforestation and generates a bunch of uncertainty about the new rules that the government wanted to create on the Amazon, or the rules that the government wanted to create about land rights, land tenure, and new environmental rules associated with that. Then in this part of my studies focuses on how this transition between the end of the conflict and the beginning of peace has affected land cover, land uses in the Andes Amazon region. Then the first idea that came up to this analysis is, well, there are some change detection algorithms that we can use for mapping deforestation, for mapping forest degradation. These algorithms allowed us to identify the moment in which there is a outlier in the time series that we are using. We are going to explain this probably a little bit more in the future with Peter. But this algorithm is called BFAS, and we were using this algorithm from 2010 to 2018 to try to see how these changes occur in areas where FARC, this illegal group, were located. And I also have the opportunity to go to Colombia, and I went to Colombia in 2019, and I was there with a group of forest combatants, with campesinos or small farmers, people from different international agencies, to try to understand all these maps that we created using this algorithm, try to link those maps with the perception, with the things that were happening locally. Then we talked to them about, oh, can you explain me what is happening here? Why there is deforestation here, or what is not deforestation here? What is occurring here? Why there is a huge amount of deforestation in this region, but not in this other region? Then we established a bunch of different interviews. We show them our maps, and we create this map, for instance, that we can see here. In this map, we divided the deforestation in 3 different periods. During the wartime, which is from 2010, 2013, during the negotiation process between the Colombian government and FARC, which is the yellow color, and after the signing of the peace accord. Then what we can see here, after we accumulate all those disturbances and we standardize this data, we can see that just after 2017, when the peace accord was signed, we can see that there is a lot of red color here, which basically means that in that period, it was more accumulated disturbances than in the period of negotiation or than during the period of wartime. In other words, each hexagon here represents the highest amount of deforestation in that period. Then we can see now that everything is red because it was a amount of deforestation after 2016 that doesn't exist before. That is okay. That much showed us something, right? Showed us like some indications about the changes, some indications about where are the new hotspots of deforestation, but we don't have any idea still about what kind of land cover are there, what is the land cover change that has been existed in this region. Then in this second part, we decided to use Landtrender. Landtrender is also a change detection algorithm that uses all these historical record from Landsat data, using Landtrender plus some machine learning algorithms such as random forest. We improve the spectral data from Landsat across time. We fill some gaps, we create some fitted information that allowed us to create much better, more consistent land cover maps for Colombia. And we did this process from 1988 to 2019. In this map, for instance, this is a protected area in the Andes Amazon. You can think that in Colombia, which is a tropical country, there is a bunch of clouds all the time. By using this algorithm, using the functions that this algorithm provides us, we can create, or we can reconstruct or improve the satellite data and create videos like this. Every single year, we can have a picture of this protected area in Colombia without any clouds. You can see that it's very clean. It's very difficult to get clean information. By using this algorithm, which is very important to use it, we can clean this data and we can create much better information that at the same time is going to help us to create much better land cover maps. And the sad part here is like, In the beginning of this video, everything was red, which means that everything was stable forest. But right now in 2018, we can see all these yellow patches deeper into this protected area, right? And all this part here is basically, or is completely fragmented with new huge patches of deforestation. And well, in this, using this algorithm, we create this map that shows us the change map between 1988 to 2019. This is the map difference between these 2 years. In this plot number 8 here, we can see the annual change. And we started to see that after the negotiation process, deforestation started to increase a little bit. By right after the peace agreement seen in 2016, we can see this giant change in deforestation that show us like something happened, right? Something is happening at field. There is a new role of institutions here. There is the outcome or the exit of this FAR group that has their specific environmental rules. And right now there are no rules, then everyone is doing whatever they can do to get more land. We can also see these transitions in a different way. We could say, okay, let's see, like during the conflict from 88 to 2012, the amount of a stable forest was about 14.6 million hectares. But right after the post-conflict, that value decreased in about like 400,000 hectares. We can also see another kind of transitions, the forest to agriculture, during conflict, during post-conflict. We can also see if there is something about secondary forests, because it seems that during the conflict, secondary forest remains stable and actually increases a little bit. But during the post-conflict period, we lost a bunch of secondary forests in Colombia. Then this is very sad because secondary forest is like a buffer that might protect pristine or virgin or stable forest in Colombia. That is good as well, because now we have in the beginning a good story about deforestation and degradation. After that, we have land cover maps, but now we are gonna focus a little bit more in land uses, right? In Colombia, we have in the Amazon is well known because there is Coca plus for production of cocaine, but there is also a bunch of illegal cattle ranching. And in this part, we wanted to detect all these 2 different land uses. The plus that has been using for producing coca, to establish coca farming, and what plus has been established for illegal cattle ranching. For doing this, we use, is this not check detection algorithm? Is a technique called semantic segmentation. And in this, the idea here is that rather than classifying every single pixel in the image, we are gonna focus on classifying objects in the image. Then we have here, for instance, a dog, 3 chips here, and the background that we might think that is, for instance, forest, right? But the idea in this concept is that, okay, we have this dog could be a small plot of coca, and these 3 chips could be like a bit far with cattle ranching. The idea here is to try to delineate, try to get those patterns, special patterns that exist on landscape, but not at pixel level, it's just an object level. Then we use our Landsat satellite data for this, and we use deep learning algorithm that is basically a bunch of different convolutions, a bunch of different transformations that we do to the data to try to understand the patterns associated with the field data that we have. In this case, for instance, the map in the middle is the reality. It's just this is a river, the blue color here. The gray color represents cattle ranching farms, and the white color are those smaller coca plots. In the reality, the satellite image like Landsat looks like this. It's like black is the river, the red color is forest, and the yellow color is like a change, right? But it's very difficult from our eyes to say, okay, this yellow color here is for cattle ranching and this one is for Coca. By using these deep learning modules, we might be able to create something like this that is actually very similar to the reality, right? Then we are, in this case, detecting something or differentiating something that is extremely difficult to differentiate using these advanced techniques of deep learning. And we can produce maps like this. Then in this map show us the amount of the persistence of cattle ranching across time is basically the trend across time, and the persistence of Coca plots. We can see, for instance, in this magenta color that Macarena, in this protected area, there is a lot of Coca in this region. There is also a lot of Coca production or Coca plots in the Nucac, which is an indigenous protected area. We can also see here in this part A, there is like a transition from, let's say, higher Coca to now cattle ranching. And in B, in this panel B here, we can see that is a giant new patches of illegal cattle ranching outside of the agricultural frontier. This line over here was created by the Colombian government in 2018. And they said, okay, everything in this area, in this hash area outside here is illegal. All the legal agriculture should be from this line towards the north and outside of protected areas. Then everything that is outside of this line here or in this hashed area is illegal in Colombia. And we can also see that all these, there is a bunch of different patterns here about the amount of Coca that has been increased across time, the amount of cattle ranching that has been increased across time. It's very interesting to see also that in Colombia, when sun eradication campaigns started from 2013 with a bunch of fumigation, aerial fumigation, Coca decreased. Coca decreased a little bit within the agricultural area, but outside of agricultural area, Coca remains stable and even increases more. Well, I don't want to describe all these patterns here, but the key part here is basically that currently in Colombia, we have about 50,000 hectares with Coca plots, but the area with illegal cattle ranching here is about 3 million hectares. I mean, the amount of deforestation associated with Coca is tiny, is ridiculous small. And this is something that we have to change in the narrative about the Colombian government or some narrative that people create, that in some cases people said, oh, all the deforestation is associated with Coca, which is not true. Most of the deforestation that occurs in Colombia and also in other Latin American countries is mostly associated with the establishing of cattle ranching, no Coca production. Well, some implication of these are like, well, the peace agreement in Colombia is a document for about 300 pages, and the word forest only appears 3 times. Forest wasn't a central element in the peace accord in Colombia, which is very sad, and we can see now the consequences of not creating these like a good agreements, at least in terms of the environment, that incorporate forests. And we could say, oh, well, forest is a victim of a premature peace, right? If we could code this word peace, or we are in a post-conflict period right now, but forest has been affected a lot in Colombia in a way that it hasn't been affected before, when FARC, this illegal group, was there creating their own environmental rules. And people respect the FARC rules because they can kill them, but it was the government for many years in the Amazon was basically FARC. And now that they left this region, There is new groups, there is new people that is taking advantage of this power vacuum and is creating new environmental rules that are affected forests. We could also say that there is a very fast expansion of pastures. And most of those pastures has been becoming for establishing new coca plots and new new farms for establishing cattle ranching in Colombia. There is investors from another bigger cities in Colombia that are investing money in the Andes, in the Amazon region, for clearing land, because they think that in the future this land is going to have more value. For that reason, we might see right now this giant expansion of deforestation in Colombia. There is too much also like uncertainty about the new rules that the government wanted to create. There is also there is no incentives for creating something that might be sustainable across time. The current government, they don't want to accomplish the points that were agreed in the peace agreement. Then all this situation about this peace agreement has been very unstable during the last years in Colombia. We might think that in Colombia, deforestation might continue because there is no clear path towards the future of saving forests or keep forests safe in the next years. Yeah, I think this is a summary of the presentation from my dissertation. I would expect from you guys questions. Well, there is a
Thank you so much for that, Paulo. You did a great job. And I think hopefully got a lot of interesting questions coming up with it. So I really appreciate what you shared, you know, having been along on this journey for a couple of years now and seeing what you've done. So I'm really impressed and really appreciate you kind of bringing this different perspective about what might be changing things back there, you know, behind those pixels, and what we might be able to see both from space, but also being able to kind of look back in time with that local knowledge that you have, right? I mean, without understanding people in that place, it's really hard to make sense out of some of these stories that you were presenting to us. So I just want to say thanks you so much for taking the time today to join us and to talk about, you know, the forests and what's happening there in Colombia. I think that's really great. And I'm just going to jump in here, Brian, and QA a few of these questions for Dr. Paulo here. You know, so Paulo, I think, you know, we got a lot of, you know, I think this is kind of provoking for a lot of us to just kind of focus on measuring environmental variables, right? What is the pH of the water, or how much tree cover is there? And so let me just ask, you know, how did you bring the people into this story? Were there any references or things that we might be able to suggest to students who might just be making some, you know, environmental measurements? How do they connect that with people, or how might they approach that?
That's a very nice question, Peter. It's very difficult to connect in some cases with, in this particular case, if you are going to talk with people that has been affected by conflict, right? There are people that they don't want to talk about them. People that were fighting against the government, they don't want to talk about them. People that were establishing coca plots, they don't want to say that, right? Then the first thing that I did to get connected to these people were establishing some connection with some local agencies, very, very local agencies of field that has some kind of local recognition, at least for everyone. Then I was doing a bunch of calling from here to the States, to Colombia, try to communicate with some people, try to establish some initial connections. I talked to park managers in Colombia that they were my first link towards talking with as far combatants. Then that part was a little difficult to establish in the beginning, but in one moment I were there, I had the opportunity to talk to them. They were a little afraid as well, because they told me, oh, who you are? We haven't seen you here. My introduction was like, I am a student, I come from United States. I just want to talk to you guys. And everyone was like, oh, he comes from United States, but I looks like them. Then it was easier for me maybe to establish in one moment like a better connection with them. But it takes time. It takes time. It's not like a very easier process. Then my suggestion is try to talk with locals, local levels, some people that have some recognition in the society, and from there you can move forward.
I really appreciate that, because that local knowledge, that local connection to experts who might be able to tell the stories or put those environmental measurements into context is a great step for a lot of our students to take. Reaching out to the people who are in charge of the local resources, whether it be the city or whether it be a local forester. On our activity tracker, that's one of those things that we do encourage people to do, reach out into those experts. So it sounds like a very similar sort of process that you as a professional researcher does to help to understand the stories that maybe you weren't there for. So that makes a lot of sense. And it looks like Andrea had a question. So in Colombia there, who is charged with the protected areas? Is it the government? Is it non-governmental organizations? Is it others? How does that line that you were showing of protection, how does that kind of work, both, I guess, kind of at that local level, and maybe a little bit more at that country level too?
Yeah, the protected areas are, there is an agency in Colombia that is called Parques Nacionales, like national parks. And there is a like governmental agency. But what I saw for this agency is that they are very small. The amount of people that work in this agency are very few, and they are not enough to control or to try to talk to people at local level. There are few park managers that actually have to go to field every day, and there are few, and these areas are huge. And for instance, when I were there, we have to drive for about 3 hours over an unpaved road, right, to get to the place in which we have the meeting. Then and it's very complicated. And this is one big issue for these people. I mean, the agency um, has some people, but not enough. And also, because it's an agency that is connected with the government, some locals, they don't like them. They don't like them because they say, oh, you are gonna tell me what should I, how can I manage my land? How can I manage my forest, right? And because FAR were in this territory for many years, they were actually the environmental agency in many ways. And FAR were the environmental agency, not park managers, not national parks. Then is difficult. That link between, or that connection between park managers and locals in some cases, especially for protected areas, is extremely difficult. It's complicated.
Yeah. Yeah, and I think that might be very similar in a lot of different places around the world, right? And I think that dynamic between sometimes recording environmental observations and what we see on the ground, is both an empowering thing, but also can also lead to differences in values and some things like that. But I think this is a great opportunity for students, regardless of where they are, to explore and understand why the world looks the way that it does. Sometimes it's laws, sometimes it's people trying to get around those laws, and there's a lot of interesting dynamics there that I think what you found really exemplifies just the interesting stories that can come out. Even though we might see a change from space, the story behind that change is a really interesting one, right? And what motivates the people to do what they do? That's that human dimension to everything that we do.
That is a good point. For instance, in some cases, you can see using Landsat data, you can see perfect, very tiny plots in the middle of nowhere. In the middle of nowhere, and very tiny points. Okay, what is this? Well, probably it's Coca, because Coca has to be in areas in which nobody wants to go, right? then that indication landscape might help us to understand what is the process behind it. Then that might happen with Coca, or that might happen with a giant patch of deforestation. We can think, oh, this is not for Coca. This is for something else, right? This is for cattle ranching. This is for a new large agricultural project. And then landscape in some cases tell us, right, about the processes that are behind it.
Yeah. And so this brings up another question that came up that Andrea brought up. How do you identify the different kinds of cattle and coca sites? I saw you struggling with this a little bit, actually. So tell us a little bit about that process that, obviously you mentioned there wasn't a lot of on the ground data, or there was a little bit of a database that you might have tapped into, but what was your process for sort of identifying these locations that you were trying to map?
Yeah, that's a very good question. In the case of cattle ranching, Colombian government has some good maps, let's say that, for cattle ranching, at least for pastures that we can connect for cattle ranching. In the case of coca, that information is confidential because I think the UN has some databases that they have to produce. The Colombian government also has their own databases about the location of coca plots because it's information that is very sensitive. Then I was able to get just a sample of some coca plots, not the total population that we wanted, but some locations, some good locations. And with those few locations were the locations that we use into this deep learning module that help us to classify much better. And this is the good idea about like remote sensing, right? Even though we have a smaller sample of something, and it's like, let's say, well distributed across the entire region, we can use that sample to try to classify the rest, right? And using these deep learning models help us a lot to get those to get those land uses maps. I think, those were the two sources that I used: the Colombian government for illegal cattle ranching, which is in some cases not too difficult to get, but the coca one is the complicated one. But it's very nice that we can now say, hey, we can map illicit land activities from space, right? Coca is illicit land activity in many ways, but yeah, that is the process that I did for getting these historical land uses maps.
Yeah. So relying on a put together database for a lot of what you did, but I know also in there you found a lot of errors, right? So there's some authoritative databases that gave you some indications, but I think one of the interesting parts about trust but verify with all of our data, right? Even though there might be a database where somebody says this is what happened, the nice thing about remote sensing is that we can sometimes double check to see did that happen in the year that was there or in the location that was there. And so I always like that idea of being skeptical of the data that you're using, right? And this again, I think kind of goes back to that groundwork that you did, right, to sort of build some confidence, add some extra data, verify some of that initial work that you were doing, but then going back to the computer and spending some time looking at the patterns in those locations, and going back and forth between the field and the computer allowed you to maybe have some confidence in the model that you actually created, right?
Yeah, and the policies as well. For instance, we know that in Colombia, it were 3 booms of coca in some specific years, right? If we know that in 1992, it was a coca boom, it was a bunch of coca, the price was super high, then we can go to our maps, and if we see a spike, we might say, hey, my maps are actually telling me this historical boom that actually do exist. And this is something that we rely from the maps about coca, because some specific booms that it sits, that we know that it sits in some years, were capturing by the maps. Then in some ways, at regional level, we might think, oh, our maps at regional level are good. They are showing like these particular policies associated with the changes, where the increases of coca in this case. And also when the Colombian government started the fumigation processes, and the production of coca decreased in some areas, and we can see that, but increase in other locations deeper into the Amazon watershed. Because when they kill coca here, then people decided to move deeper into the Amazon, which is is terrible, because now there is more, like, deforestation is more deepened into more the hotspot of ecological importance, right? Then those are the other processes or the other problems that might exist in this case.
Yeah, and I think, you know, what you really showed with all of this is both the power of your local knowledge, of understanding the people in that location, as well as tapping into this incredible satellite archive, right? Paulo, were you one of the first people to really look at the Landsat archive in that area and look at these forest changes over time?
Yeah, in Colombia, yes, I think that that was something that I wanted to create, being the first one using Landtrender in Colombia, basically, as well, because there are studies in Brazil that use Landtrender probably for mapping deforestation, degradation, but the key value here is that we can use Landtrender not only for detecting deforestation, we can use Landtrender for creating much better land cover maps. And I spent a lot of time to try to, creating a better Landsat information and create a much better land cover maps for Colombia. And Landtrender was amazing for this process in the Amazon. It was pretty well.
Yeah. So I want to end on this this question. I think we've done a good job of answering a lot of these different questions that people have put in. What was it like to sort of to actually explore these pixels for the first time? Once you ran, you know, processing the satellite data is one thing, right? You take this stack of observations that were made, you put them through the algorithm, but describe a little bit what that discovery moment was like when you first started looking at those maps that were coming back.
That's it. Well, it's something that is very nice to see here is that the FARC, this illegal group, they have a very clear territory. They have a very clear area that they actually control pretty well. And it's very nice at the same time, it's sad to say that when they left that particular area, right? They left that area, and when they left, immediately there was a bunch of deforestation occurring, right? And it was in the area that were actually controlled. Then there's an indication of, this group were controlling this land right now here, right? They left, now someone else is taking the power, right? And now we can see the changes, the giant changes that were occurring. I really, for instance, something that encouraged me to do this research is like, I could see, I could see like, I can see all the changes that occur in this particular area. And I said, something is happening here. I have the record I can see here. And I can go backwards as well and say, what happened when they were there? Obviously, when they were there, it was deforestation, but the deforestation was very slow. And when they left, the deforestation increases a lot. Then that is the part that was, very excited to see, like, wow. And it's now it's not only when they control the territory, now is very deeper into the Amazon as well, right? Then that is like the things that I was, this is very nice to see, this is very nice to mention, this is very nice to publish or to create a note, a report, a news, because we have to call attention about this. All these changes that are occurring here are horrible, are sad. And it's very sad that our satellite data is show us all the time changes, deforestation, and we have to do something. That is the point of this, right? In one way that this dissertation or these papers contributes to create some awareness or some conscience about what is happening.
Yeah, thank you so much for that, Paulo. I really appreciate, it's sort of, to me, it's that sense of discovery of looking at the maps and kind of seeing things that other people may not have seen. That is incredible about this this particular satellite series, Landsat, and what it can provide to us. It can bring that past into the present. Why does the landscape look the way that it does? And so there's just a lot of, I think, really neat exploration that can come out of something like this. And I think, your work really exemplifies understanding the processes that we see, not just the, the pixels change colors. Yeah, that's easy to see, right? But what is happening behind it? And I think, understanding that people are the driving force behind a lot of these is really important. So I appreciate that. And if anybody has any other questions, please, continue to drop those in. We'll follow up with
I read
Dr.
something
Paulo.
here very quick.
Yeah,
But
please, if you found one that we didn't address,
yeah, I
that would be
saw
great.
something. I don't know, it disappears, but
Yeah.
someone asked me something. How can I connect these changes with conflict?
Yeah.
I didn't mention here, but we use in the first paper, we created an ethnographic research. I mean, I went to the field. I had some interviews, and I connected those interviews with the maps. In the second part, we use an econometric module that allowed us to connect the changes that we see with the causal effects. We create this econometrical model that tell us, okay, this change is exclusively associated with conflict and not something else. This is not associated with precipitation. This is not associated with population increase. This is not associated with another kind of policies. This change that we can see here is exclusively associated with the confrontation that it sits in that location. Then that is an econometrical model that someone has helped me to create. And in the latest one, in the Coca and Carol maps, in that one, we also use something of kind of quantitative and qualitative analysis, something called socializing the pixel and pixelizing the social analysis. Then we create some hypotheses that we tested, but it's more like an qualitative way still, but they are connected. I mean, the changes that we might see are associated with some specific policies that occurs across time. Then that was something that someone asked me, but I don't know, what is that question now?
No, I really like that. I'm glad that you caught that one, Paulo, because I think, what I like is that you actually just brought up a difference there, right? You use not just quantitative numbers to do your work, but you also use that qualitative, that actually that using these two different ways of collecting data or of analyzing data, it really informs your work. And so I think, to me, that's one of those exciting parts about the type of science that you're bringing forward here, is that it's not just about the mathematics, that there is this human dimension. And I think for some students, some of what we present here is just about measuring that tree, right? What's the DBH? What's the diameter of breast height? Or, those kinds of very quantitative, infallible numbers, right? But I want to encourage everybody here to kind of take this next step and to see how might you be able to bring in this social dynamic to the trees around the globe, and what's happening to them, both in terms of people planting, like we've talked about in previous webinars. People are planting trees now, right? And being able to monitor those. Why are people planting them in certain locations? Are they watering them? That policy piece, I think, is a really important part. So I really appreciate you coming today, Paulo, and joining us to have this part of the discussion. And please stick around here. I want to actually, I'm going to present some of how people can access Landsat data and how they might be able to take some of the approaches that you did and localize them to their particular area. So you'll notice there's quite a few things that are very familiar to what you're doing, and so feel free to please chime in here, because I want to give people a sense for how you can actually take what was presented here and localize it to your area. And I want to start off here by showing you that, in fact, on My NASA Data, there is an introduction to the tool and model that Paulo here was discussing, and that one is called Landtrender. And it's called that in part because it's using the Landsat time series and looking at trends over time. So instead of a point in time, what does the landscape look like today? It's more of that process, like Paulo was talking about, that, over time. We have a nice video here narrated by one of the people I've worked with for many years now, Dr. Robert Kennedy, describing how we actually look at processes using satellite data. So there is this nice introductory, I think, hook that many people can use, looking at cause and effect. Again, like what was demonstrated here, understanding that it's not just a point in time that trees are just there, that in fact they actually grow over time. And scientists use models to do that, to predict, to forecast whether those trees will still be there. And so I want to highlight that we have this lesson that I think really exemplifies and kind of sets the tone for this type of science. And I think, to me, this constructed argument supported by evidence. Well, we can use satellite data to construct why we see trees where we do, the processes that students are seeing. And so I encourage all teachers here to explore this particular mini lesson that's available on My NASA Data to provide some of that context for you with this. And importantly, I want to highlight that what Paulo has brought to us is this idea of the Landsat time series. And what is really exciting is that coming up September 16th is going to be the launch of Landsat 9. And so this is actually going to allow us to continue our monitoring of Earth using this Landsat time series that was first put up in 1972. And this is, again, you see what can be revealed by looking past and through time in the same location. And so, this Landsat time series is just incredible. Again, there are these wonderful pages that NASA and the US Geological Survey have put together talking about Landsat. There's actually some nice activities here that you can bring in about this, a little engineering design. But here at Trees Around the Globe, we like to talk all about satellites. And so there's a variety of these tools that you might explore in preparation for that September 16th launch, which is the 3-year anniversary of our Trees Around the Globe campaign. So stay tuned, because I think this will give us all an opportunity to bring in this Landsat time series and to really build off of a launch of a new satellite, which I think really works well for a lot of students and might actually bring some new interesting opportunities for research this next year. Again, there are some of these educational materials, remote sensing in the classroom, especially looking at urbanization and some of those pieces, building off of the same type of science that Dr. Paulo here, was presenting to us, looking at these changes over time that you can only do with this type of satellite data that has been collected over many, many years, unlike something like ISAT-2, which has only been collecting data for a couple of years, right? So so with that, I want to highlight, if you're looking as a teacher or as a student to get some more expertise in actually using the satellite data, NASA is going to be running this particular training using Google's Earth Engine, which is the tool that Dr. Paulo used to do his analysis. And so this might be something that if you're interested in bringing some satellite data into your classroom or helping to support your students doing their student research, this is a very timely training that actually is starting in just a couple of days. But the nice thing is, all of these trainings that NASA puts together through the RSET, the Applied Sciences Division of NASA, are available to you even after the fact. And so I want to encourage you, because there is actually the land trender algorithm that was demonstrated here is one that will be highlighted in this particular land monitoring application using that Earth Engine. So very exciting, very timely event that I wanted to highlight there for you. So I personally promised that we would give you some tools where you can actually localize and look at this Landsat time series in a similar way as Paulo did over time. And I brought this one up in the past before. It's a nice general one that has some scientific issues with it, I'd say, but it's a great place to start exploring your particular local area. And this is Google's time lapse. And they've taken a lot of the Landsat time series, and they've tried to do some of the cloud removal, like what Paulo had to do in his area in Colombia. And so the nice thing is you can zoom into a particular area, but you know, I'm just kind of curious, if we zoom in on sort of the Columbia area here that was presented to us today, you can zoom in, and then one thing that you should start to kind of see, I'm just going to zoom in to this little offshore area because those are always fun to look at over time. You notice on the bottom here, we have our year. So we're getting a yearly image. Google has synthesized and kind of reduced our data. So we don't have any control here. And that's, from a science perspective, a little bit challenging or unnerving. But what we can do is we can start to just explore and see what is revealed here. And that might lead you and your class or your students to investigate a particular area of change that you might see in this particular Landsat time series that's available. Just kind of from this, one thing I'll note is that we have a lot of cloud cover. And Paulo, this is one of those big issues that you had to overcome, I know, is dealing with cloud cover. And so before we can actually map anything on the ground, we've got to get rid of those pesky clouds. So that can sometimes be a barrier, but also a really good opportunity for students to look at the cloud cover of their area, seasonality, and trying to align that with the trees that they're trying to measure, and maybe measure from space. You know, and so, like I said, this is a great place to just start investigating and seeing what sort of changes of colors you might see that are happening. You know, here's a nice river bend, for instance, that we can see sometimes gets filled with water, sometimes doesn't get filled with water. So I like to use this as just a way of exploring a particular area to start off with. You know, I hope that people have explored this one in the past. And Brian, if there's anything that comes up in the chat, this is very open-ended, so please feel free to, you know, stop me if I go.
Peter, there are a couple of questions in here.
Perfect.
From Bo. One was, I shared the link from the Mine Asset Data, the activity that you showcased, so that's on there. Couple questions from Bo about having an RSET link for the classes, I guess you mentioned.
I'll drop that in right now.
All right. And another question, how do we use Google Earth? How do we use the Google Earth area you are demonstrating? I guess, you know, what's the easiest way to get into what you're doing without having to go through a lot of obstacles?
Yeah, so the nice thing is it's very self-evident. There is a little explanation that goes along with it. Over on the side, when you first come here, there's just these stories that you can use to go around the world. And it will zoom there and it will start playing. And you can have students explore particular types of stories that Google is highlighting that show particular types of changes, like glacier changes, for instance, or other things like that. And so it's overall pretty self-explanatory, hopefully, once you go there and spend a little bit of time. And you can share them, and you can do some other things like that in kind of typical Google fashion like that. So again, you know, this is really a more of a viewer that can be used to help support the science investigations that students are doing. And so I dropped that link into the chat, and so hopefully people can find that and explore it. Again, you know, you can actually see some fun artifacts of the way that Google has done their processing, like the halo around this glacier and some things like that. So one of the questions with that cause and effect is, what are errors or limitations with satellite data? And I'd say, you know, with the type of work that Paulo was putting forth and the type of work that I brought forth as well with this, cloud cover is our biggest challenge, and making sure that we're really seeing the ground and that we're not mistaken, in this case, snow cover or some of those things for actual changes. So this is, I know, one thing that Paulo had to spend a lot of time doing, and this is where that ground data helped, is making sure that what he was seeing from space were real changes, and not something that was introduced by cloud cover or some other satellite mismeasurement inside of there. So I like looking for those kind of potential errors or weird things that make me go, huh, what's out there? And let me go out and actually make some measurements and then come back to the satellite data.
Another,
right.
Peter, another interesting question here from Bo. It's what is the process of clearing cloud cover? What do clouds look like in these shots?
Yeah. So typically here, actually, I can go. Here's a great place to explore the cloud cover, because here on NASA Worldview, what has just recently come in here, and we've highlighted this tool in the past, there is this new harmonized Landsat Sentinel 2 time series. And this is something that I know Paulo is just starting to work with to see, can we use the European Space Agency's Sentinel-2 satellite, which is very similar to Landsat, to improve our monitoring. So previously, he was stuck with 16-day to 32-day or that kind of thing to be able to make an observation in a location. Well, now using this almost daily 30-meter imagery, you can go to Worldview here, and it will actually walk you through. And one of the things that you can that you will then see is you can zoom into an area, and you will actually start to see the higher resolution imagery that's available. And so sometimes you actually have to change the dates to do that. But here we can actually start to see the cloud cover that's there. And so, Bo, to your point, what we're looking for is these white areas like this. Let me turn that on. And now you can actually see the difference in our satellite resolution between our MODIS satellite data, where things are a little bit blurry, and here with the higher resolution Landsat or Sentinel data, you can actually start to see the edges a lot more crisp of the edges of the cloud cover. And so the first thing that we do is look for these white areas like this, and there's actually a thing called a cloud mask that comes with this. So the first thing that we're doing is we're trying to just find these white areas, and then usually the shadow will be a black area that is very similar, kind of off to the edge. Like an area in between these clouds is a typical shadow. So that's the first thing that our atmospheric scientists have helped us to do is identify the clouds, identify the shadow, and then we remove those. And then we're left with these brown areas or areas that are cloud free. And that was, something that Paulo did describe that he had to go through and do. And then sometimes do what he described as gap filling, right? So if it's cloudy for 3 months straight and you can't see from above, that's where our globe observers and the observations on the ground really become valuable, because we can't use that space perspective to measure trees getting cut down or the cattle in that area. So that cloud masking and cloud identification is the first step in our land cover mapping that we have to do. We like to deal with surface reflectance. So, how does the sunlight actually reflect off the surface? So I appreciate the atmospheric scientists that sort of take care of this piece and get that away so that people like Paulo and I can focus on the land cover and the surface reflectance. So when you're kind of doing these things, that's the first part that we're always asking is, can we see the ground? And so that's the first big thing. And this NASA Worldview site, again, is a great place to just kind of start and kind of looking at this, because it's very user friendly and a viewer, and you can start looking at that information. But I want to kind of put you back towards, you know, Google's Earth Engine or some of the NASA tools allow us to get at the real pixel values, the real numbers. And that's one of the things that Robert Kennedy mentions in that cause and effect video. We're dealing with numbers with these satellite images, right? So we can do math, we can do all kinds of things with that. And so we turn them into pictures, but at the base level, they're numbers. And so one thing that I've highlighted in the past is it can be a really valuable tool that is now available to us, is this one called NASA the Appears tool. And so here you can just put in sample location. So what's a latitude, longitude, and you can actually get back those numbers. So we have a lot of viewers, like I've shown you. Google Time-Lapse is just a viewer. That World View, just a viewer, right? And we want to help get our students to the numbers behind it. And this is one particular tool, NASA Appears, that allow you to really easily do that. And so this is something that you might come back for our tutorials that we'll be doing in July and August, where we'll dive into this a little bit deeper to get there, so that your students can actually work with the numbers itself. Thank you so much for adding that link inside of there. And I do want to highlight a final tool that I've really found to be useful recently. And this is called the Sentinel Hub. And this does allow you to get into some of that remote sensing data, both from the European Space Agency as well as the United States. And you can see that you can pull up the Landsat archive inside of here, as well as various other satellite data. And so it's just, again, you can just search on this, and I'll drop this one into the tub. And here you can see the satellite imagery that's available inside of here. And so I can just click on one of these, visualize, and there's a lot of different ways of looking at this. And again, you know, these are some more advanced ways of looking at the data, but we can look at it in that natural color. And here, again, a good demonstration of clouds being that white area, forest being kind of that natural green area. And this, again, is just a really nice, easy viewer for students to start looking at a particular area and starting to be to understand that satellite view. We can even turn it to vegetation, photosynthesis, right? So this is you know, hats off to the European Space Agency for actually giving us another nice tool that I will drop into our browser right there, so that you can explore this one. Again, a great way to be able to actually access this satellite data. You can even download this image right here inside of there, so students can start to get very recent satellite data with what they're doing. And we have, you know, as anybody who's come to these before, I've got lots more of these websites. And so let us know what you're thinking about, or what you'd like your students to work on. You know, celebrating the 50th anniversary of the Landsat mission, I really would like us to, and maybe consider this cause and effect, you know, thinking about what has happened over the last 50 years in your location, and how might your students be able to use the globe or the ground measurements to make sense out of that. Remote sensing is one tool. The ground measurements are another tool, and let us know what we might be able to help provide, so that students can understand the world that they're living in today. And with that, I'll turn it back over to Brian.
Thanks, Peter. Yeah, that leads us perfectly into what we want to do in the last couple minutes. I know it's only 2 minutes until half past the hour, but that's okay. But we just wanted to just, you know, talk a little bit about, and oh, sorry, and Peter, if there's any questions in there that we missed that, you know, in the chat, you know, take a look at. I think we covered most of them. There's a couple in there maybe. So, but what I wanted to talk about informally right now is, and as Peter mentioned, if there's anything we can help you out with, and, Peter just did a great showcase on how to use different online tools to, highlight that Landsat time series in your area. And that was built greatly upon Dr. Paulo's presentation today. So that was great stuff. And it fits so perfectly into what we want to do, continuing with the campaign, and specifically July and August, the specifics about, what we want to, help out with, what we can help out with. And the only way we know exactly what you would like to do or what your ideas, doesn't have to be concrete ideas yet, we're in planning stages. So, what do you want to see, your students investigate? What would you like us to help you with your students in the research? And it was great because we had a lot of great IVSS submissions this year that were aligned to the campaign, focusing on things like tree cover and greenings and land cover, and a couple carbon ones here and there. So we're super excited about that. But we want to be able to have more students do these research projects, submit them to IVSS or any local science fairs or competitions in their area around the world. I know they happen everywhere. And I know that, we're still in a weird time right now with the pandemic. And I know a lot of you folks who are coming from all over the world, that the rules are different in your countries. Some are still in lockdown, maybe in lockdown, some are easing up, some are at certain percentages of people in public. They don't recommend you go outside and do lots of things. So there's lots of things going on. So that's why we're trying here in the campaign to focus on how you can, do a lot of things by looking at the data that's already existing that you may not have yet, that you may not be able to have gone outside yet and taken observations. So that's what we want to really try to focus on, coming up with some ideas of this. So, I'm going to open it right now. If anybody wants to unmute, but a couple questions that we want to just throw out there. We don't have to do them in order. If you have any answer to any of these questions based upon the time that we have left here, we don't want to go too long because we're already an hour and a half in. But a couple of those questions again for our discussion. What are you going to investigate in the upcoming year? Meaning, what do you want your students, what are you going to focus on in potentially your teaching or working with your children? What you want them to, what do you want to focus on? What's the science you want to do, and what are type of local environmental observations you can take for these projects? What do you want us to feature in upcoming webinars? What are some ideas that you have for topics? As I mentioned earlier in the beginning, in the introduction, what are some things that, or some even people or researchers that you think would be a great fit for our campaign to have the rest of the participants from around the world here and focus on? So let me open it up now. If anybody has any ideas or questions, we just want to chat. This is all informal, so you don't have to feel like you have to, say something. You can put it in the chat and we'll bring it up for discussion. So if you want to, go ahead and unmute yourself and, let us know. Couple things in the chat here. I noticed that Bo mentioned, these are a couple really cool, ideas of, things that, can be done potentially.
I'll talk to it for a minute because I'm doing my paper with 2 farms in Ohio and one in Northern Ireland. And we could look at those farms with help of kids over time, either with Globe Ireland or with other kids around the world, and understand some of how to use these sites you just suggested and get trained on them. But also, I know that in Ohio, Janet and I are going to be looking at training some child outreach coordinators with the state university. And so I know that there are more people who could use your new materials, and we want to do that with you. But I want to say LA is in stress. I rode the buses this weekend and I was bullied by a crazy person, and there were all kinds of signs of stress in cities across the United States. And I wondered if we can get people carrying waters to trees and looking at air quality getting better, or anything we could do with these wonderful tools.
Yeah, so Bo, to that point, we did make a presentation to the with the LA County Library for our Trees Around the Globe campaign that we recently did, and I know the forest fires, all kinds of things, urbanization happening in that area is one of these things that we hope that by there, some of the tools we present today are great places for students to start looking at that environment around them, and starting to think about um, that sustainability and kind of how they interact with that environment and some of those stresses, right? The loudness, urban heat, populations, parts. I know that that's something that Paulo had to look up, and think about people in relationships to the land around them. And so don't have an exact thing other than we have those tools and would love to kind of help support and figure out how to move those conversations forward in that way. And we're always, Brian and I, we have the tools, we don't have the audiences in that way. And I think each one of these things, I found it to be empowering, similar to Paulo. When you start looking and bringing these things together, you start understanding, and that right there hopefully is empowering and can help people understand the world that they're living in. It sounds like I've said that about 8 times today, but yeah. So, Bo, I think, last year, it's interesting what can happen between now and, September, the beginning of the school year, and sort of those priorities. Last year, fires were the ones. And so, to me, those are some great opportunities to explore and to think about how we might be able to support that. Long answer, but
That's perfect that you repeat that often, Peter, that that's what we're trying to do in the campaign, that we have all this data, we have all coming in from all these different directions, from satellites, from instruments on the space station, ground-based observations, instruments on the ground, all that stuff. And all of that science doesn't make any bit of sense unless you apply it to the real world and how it makes sense in everybody's lives. Because that's why we're studying, because we want to understand what's happening with our planet. And how do we do that? We look at things like this. We look at time series, we look at the data, and we figure it out and how it makes sense, in the real world. And I think some of the things that you mentioned, Bo, on here are definitely real world perspectives, things that are happening in the real world, for sure. And that's one thing that we want to continue to focus on with the Trees campaign, moving forward, that we focus on real world applications. With all the NASA satellite missions that are out there, every one of those satellite missions has a linked applications program with people who are applied users around the planet, around the world. So that's what they do. They come up with research projects like we want students to do. Get the data, be able to look at that data, analyze it, visualize it, using online tools, using validation instruments, things like that, to bring that all together to figure out how that maybe smaller project, even to a larger project, but a smaller project, makes sense globally. Anyone else? Anyone else have any other ideas specifically, like they'd like to see, in the next year or so, something specific,
I was reading a little bit the Bo question here, and I was thinking a little bit about Portland and a little bit about the distribution of trees or the distribution of gardens in Portland. Like try to map forests or at least green areas at urban level that might help us to say, hey, okay, probably we need more forests in this particular region for making the city a little more fresh during the summer, right? I have a friend that was she was working mapping gardens or greenest areas and differentiating gardens against forests in Portland to try to identify what is the amount of probably food that people can put in here in their houses, right? In Portland, in any other city here in the United States. It will be very nice to try to move to remote sensing towards urban areas, right? Because in some cases, remote sensing focus a lot in deforestation, is mostly in rural areas. But maybe now that we have the ability to having more satellite data with the pixel detail that is smaller now, then we can think more about mapping more specific changes, like things that maybe we haven't think too much before, but something like that might help to create a much happier environment, or more fresh environment, as Bo was suggesting in her question. I forget to turn on my camera, but yeah.
Thank you.
I really like that, Paulo. And here to just kind of demonstrate that, I think, you know, this is a great opportunity, right? Like looking at not all green means the same thing, and so you know, you know, mapping out that greenness in your landscape. Here we can see some different agricultural fields surrounded by this airport that's right there, and so starting off with a greenness image like this, and then saying, hey, let's go out and make some measurements. What's actually in these locations is a great thing. And then you can bring in that, has it always been like this question? And that's where the methods that you presented to us today, Paulo, allow us to look back at that question of, are trees growing the same today as they were 10 years ago? Or are they still in the same location? When were they planted? Those sort of questions can also be answered with that. And so, you know, here's just one quick, easy, you know, way of seeing how green is your landscape, and then being able to ask the question, is this trees or is this some other vegetation? And I really like that urban community garden or gardening aspect of land cover. I really like that, Paulo.
All right. Anyone else have any thoughts or ideas? And I'm going to put in the chat here, you know, if you come up with ideas, you know, please feel free to shoot me an email, because we're always interested in, you know, we don't want to be, and you know, we're not a campaign team that only does what we think should be out there. You know, we do a combination of that, and we want people to let us know what they want us to showcase. If we can find, if there's something going on in your area and we can find, you know, some type of data or whatever, whether it's globe data or NASA, you know, satellite airborne, you know, ISS instrument data that aligns to what you're talking about, what might be happening in your area environmentally, you know, let us know. Because if it, you know, specifically if it's trees and land cover, greenings and carbon related, you know, we definitely want to be able to get that out there, because we are here for you as a campaign. We want to bring you as much information, bring you as many resources and tools that we can. And, you know, in the 3 years that we've been doing this, we've had a great response from people saying, hey, we'd like to see this, like to see that. So that's great. So, you know, we're always open for that. So feel free to shoot me an email. I'll pop that in here as well. So, you know, maybe a couple more minutes being on the webinar, because we're 42 minutes past the hour. So a couple more minutes. So, but we love this, that it's actually gone this far and we have all these people still remaining on the webinar. So that's wonderful. That just says, you know, how great. I know other people had to leave for meetings and stuff. So I'll pop this in the chat.
So if I may suggest something.
Yes, please.
Yeah. So this year you really did a good job with the web page, because you had lots of steps how to go on through the campaign, and some school activities, class activities like carbon games, etc., etc. You know, but sometimes the kids do not understand the whole picture from once. So maybe it was also good to add some, let's say, small pictures, since the global warming affect our environment and the trees and everything. Maybe we can create some, you know, game that they make a small mesocosm, and they alternate the temperature to see how it affects their few plants they will plant inside. So that way they will, you know, have a small picture, and they will see from their hands that something's going on. If it just change the temperature for 1 degree, that, you know, plants will look different. They will change the color. Because when you tell them that, you know, the Earth has been changing the temperature for 1 degree, they really, so 1 degree, what? They don't have a clue what that means. So maybe to make some activity, you know, the small activity by which they can feel the difference. So it would be, I will try to add this to also to my class next year with the Tree Around the World campaign, because I have seen that there is some problem with, you know, understanding the global things. So let's start
Right.
from the hand putting globe. Thank
I
you.
like that, Michaela. And you know, in fact, you know, it's very similar to sort of that question of the model. You know, I showed the model earlier about, you know, satellite data. That's one type of model, and I like what you're presenting as another sort of model that we can use, where students can get a little hands-on like that. So modeling is really important to all that we do, whether it be on that hands-on like that or starting to look at the satellite data. That's a really good suggestion.
Yes, thank you. I'm just putting that in my notes here. How about anyone else?
So I did see Marcus, you know, put in the chat. Could we learn how to use better use the ISAT2 data? And yes, Marcus, that I think that will be something that we'll come back to as well. There's some new products that are actually just coming out with the ISAT-2 and the JEDI laser that's on the International Space Station that is actually combining together the Landsat data that we presented today with this ISAT-2 data, so that we actually have some more tree height estimates that students can compare themselves to. So there's some fun, exciting science that's coming out that Brian and I will come back and we'll talk a little bit more about that the laser data and what we might be able to do with that. That's a great one. Some experimental viewers are coming out that make it just a little bit easier to look at that. Plus all that data, right, Brian?
Yeah. Yeah. And as you know, Marcus, it's not the easiest in the world to get a match as far as getting a tree height, you know, from Globe and ISAT-2.
Yeah.
You know, it's tricky. I mean, you know, I've been working with ISAT-2 for a long time, and in my neighborhood, I've found 2 photons, you know, in 2.5 years that actually align to some of the trees in my area. So as you know, clouds aren't our best friend, you know, with ISAT-2. So there's a lot of missing data because of, you know, either thick cloud cover or the cirrus clouds that basically reflect a lot of that laser light from all around from the ice crystals. So, but yeah, so that's a great idea. But yeah, as Peter mentioned, you know, these new tools that are coming out will really help in this as well. And that's great. And Valerie, did you want to say something? Valerie is here. She's the communications lead for the ISAT-2 mission.
Oh, yeah. Hi, Brian. Thanks. Yeah, I wanted to mention, too, that ISAT-2 as a mission will accept requests from groups or individual scientists or anybody to actually make a scientific request to off-point the satellite. So ISAT-2 was originally, the main focus of ISAT-2, of course, is to study the heights of the ice in the polar regions and around the world. But the secondary product is looking at tree heights, vegetation heights. But we don't get, as Brian mentioned, we don't get that dense coverage like we do over the poles. However, an individual, a scientist, a group could submit a scientific request to off-point the satellite. That means the satellite will actually gimbal and off-point to look at a certain area. So that's a possibility if a group wants to, you know, if there's a big scientific reason to do that they have to make a command to the satellite, of course, but that's an option. So maybe one of the Globe groups or as a group together could even make a request for that and study the different other satellite data and compare it to the ISAT-2 data. That could be a really cool thing to do, to use all the satellites to study a certain area. So yeah, that's all I wanted to say. Wonderful webinar. Thank you so much, everyone.
Thank you, Valerie. Yeah, that's great.
I really appreciate that opportunity to take advantage of the off pointing. And that's something that I've heard about, especially with some of the recent disturbances that people have experienced. And so I definitely encourage people to think about that as a great opportunity to have that connection and to be able to get the data where you need it. I think is exactly what Marcus was sort of referring to. And I think one of our challenges. So thank you, Valerie. That's a great offer and a reminder about how science can happen.
And I definitely think you're right, Peter. That is definitely an obstacle with our campaign is, getting that, those measurements, exactly where we want them. It's tricky. And that there's many facets of my statement there, which I'll leave it at that, but there's many different things going on there. But yeah, so super excited. All right. Last chance here. Anybody? I want to end it about 10 minutes before the hour.
I just want to say that was really, really interesting. And going from listening to the research that the scientist was doing to having Peter share with us, ways that we've got all these amazing scientists who are right here to learn. Absolutely fabulous webinar. So thank you so much for your time and energy. And thanks to everybody from around the world. Trees Around the Globe is really happening here who joined us.
Thank you, Dorian. Anything else, Peter?
No, I'm just excited for to collect a whole bunch of data and to get another satellite up there to collect more information. And I pay attention. We have a training at the Globe annual meeting looking at both Globe Observer trees and Globe Observer land cover. Come to those if you want to learn a little bit more, if you want to practice. We're here for the next 2 months to really help support teachers in getting planning and getting ready for this next year. So we want you to be successful and maybe bring in some of these new tools, which can be intimidating. And so, definitely let us know what you might need. Sometimes videos, other things like that are maybe really easy for us to produce and to help you be able to get this into your classroom and to help your students be successful in their own research, but also contribute to this global challenge of mapping, measuring, and monitoring.
Remember, we always do have the online tool section on our campaign webpage, and I'll throw that in the chat right here, because a lot of those are videos from when Peter was doing demos as part of the webinars. There are a couple on there from that I did and some other folks, one from NSIDC and Open Altimetry, but I popped that in the chat because that shows you what's there. And what Peter talked about today, we'll pull that one out of this webinar as well, and then we'll pop that up online. So within the next day or so, you will see a recording of this. You'll see a recording. I will send an email out, say the recording's ready to watch, and there'll be links, all the links that people shared in the chat. We will pop that onto the webinar page as well, just under the recording. So thank you all, and stay tuned for the announcement of the July one. We know a lot's going on in July and with Globe, because a lot of stuff is going on. So we have to really plan the best time to do this, the next webinar, because of the whole week-long, Globe annual meeting as well. So we don't want to do it that week for sure. It's going to be a busy week for all of us. So thank you all, and we're always gracious for you to be here and be a participant in the campaign. And we love this Trees Around the Globe Student Research Campaign family. So thanks so much. And thank you, Dr. Paulo. I should have mentioned that. Thank you again, Dr.
Thank you for inviting me.